Hello everyone. I was hoping to perhaps show you this later on when it was 100% where it should be, but I'm quite excited and I just wanted to show this off to you. And this is my new brewing setup. Those familiar with it will probably have spotted already that this is a RIMS system. I'll run it through quickly and then I'll go in more detail for the brewing nerds among you. Okay, so this is primarily for mashing, which is the conversion of starches to sugars by the release of enzymes, which involves basically holding grain at a certain temperature to release enzymes, and depending on the temperature you get different enzymes which will give you either a sweeter beer, a more full-bodied beer, or a lighter beer, drier beer, whatever. And you can also add more complexity by doing steps, and this easily allows for steps. Okay, it also doubles up as the boiler. This here, it's a 30 litre HDPE, it's a brew bucket basically, a big brew bucket. It's obviously rated for the temperatures and some. It can do the boils no problem. So if we look inside, we see at the bottom there is a perforated grill, that's called a false bottom. Two heating elements, those are mostly for the boil. And I've just steamed up the lens there. But basically we've got at the bottom 3/8 inch barb, a bit of reinforced hose to this, which goes to the tap. Okay, it's PVC reinforced hose I'm using because it both has to withstand the temperature but also the weight. Now normally I use silicone hose for heated stuff because it doesn't collapse under the weight, but because it's not reinforced it will collapse under the weight of the grain which gets put in here. This, by the way, what I'm doing here, I'm just doing the tuning run on the PID, which again I'll explain. The liquid comes out of this valve. Obviously, because the grain's gone in there, the false bottom there is to filter it so that the grain stays in there and the water or the wort comes flowing out, leaving behind any particles. It flows out here through this tiny little pump, tiny little 12-volt pump. I didn't believe it would even last 5 minutes, but it's worked absolutely fantastically. Comes through here and into the bottom of this, which is the RIMS tube. At the bottom of the RIMS tube you've got a 2000 watt heating element. Comes up to about here. The wort flows in and past the heating element, heating as it goes. And because of the fact it's recirculating, it doesn't scorch or anything like that, you get a nice even temperature, which is what this is all about. Flows up. At the top here, this is our PT100 temperature probe. Come back to that again. And out the other side. This is made up of BSP stainless steel fittings. Obviously, being stainless, it's all lovely and food safe. Also very easy to clean, which is great, because I hate cleaning. Yeah, these are they're quite expensive to buy, but you can make something like this quite easily and fairly cheaply. The tube in all the fittings costs about 60 quid, which I consider quite a bargain. The only thing you will have noticed, which I wish wasn't the case, is that it's made up of lots of little barrel nipples. This was just purely economics. They had them on offer, they were much cheaper than buying one long barrel nipple. Unfortunately it means there's about 5 times as much that could leak, but I haven't had any leaking problems, with the exception of the heating element, which I'm going to come back to. So that's the basic process. It filters, it separates the grain from the water, pumps it through, heats it, goes through, it maintains a constant temperature. So that's the body of it. There's the brains. And I must admit, I was slightly concerned someone might think this is a bomb or some such. It's not. It is it's not just temperature control, it's my control box. It's powered through 2 plugs. The reason for that is because it will be used to control 2 heating elements sometimes. So you know, you've got to they're 2000 watt elements, 230 volts or 240 volts. I mean, went and changed it back to 230 at least. Anyway, so that's it's about 10 amps per element, and our plugs are 13 amps, so you can't run it through one plug, you're going to run it through two. I could get a high power thing installed, but I much prefer the versatility because I can run this outside if I wanted to, or something like that. So, two plugs. One is the main power that does everything, including the heating element. The other is a separate circuit which runs this trimmer, which will be the other heating element. Everything else apart from this element on the main circuit is low power, so it's the perfect amount really. The main power comes in. There's a key switch on it, which I'll admit is mostly for show. Makes you feel like you're launching a missile. Also stops people messing around with it. I don't like people messing around with this because you can do it wrong. This is the main power switch. There is a reason for the missile style cover, and that is basically, as long as that's down, it's all 100% definitely off. You don't have to worry. If it's up, it can be on. So that does actually have a function. And I will be labelling all of these. I was going to get one of those old-fashioned perforated, not perforated, embossing label things. You know, the little red strips with the. But as it is, I spent ages wiring this, so I know exactly what everything does. But I will get round to it. Main power. This turns the PID on or off. This one can cut the connection between the PID and the solid state relay. This is important because really I don't want the element on all the time. When I like to be able to turn the PID on, set everything up, then turn the element up, prime the pump, get it flowing, then turn the element on, you know. So doing it this way works out pretty well, I'd say. This one controls the pump, the recirculation pump, this little tiny fella here. And this just runs through, it's a 12 volt DC pump, so there's a little transformer in there. The 10 amp transformer powers that. This is the power for the trimmer, which runs on the separate circuit. I'll get to that in a second. This right here, that's the heatsink. There's two solid state relays on here, so I decided to mount the heatsink externally so it can actually cool effectively, because I didn't really want to mess around with fans in there. And then you've got the two outputs. You've got the, this is the PID output, this is the trimmer output. The reason you might have noticed here, it's only got one plug. This was an oversight, and I couldn't think of a better way of fixing it. Basically, I didn't realise that these dual gang plugs only have one feed. So one feed for both plugs. Now, this is outputting in a special way, so it'll be outputting to one different than it outputs the other. So this one might be going bang, bang, bang. This will be on all the time at half power maybe. So they need to be fed separately. So this involved a bit of drilling and modifying of this, which meant that I couldn't actually get this plug back on. So for aesthetics' sake, I decided to cover it with a bit of paper. How very high tech. In the back here, we've got a little terminal block. I thought of using plugs, but I couldn't find anything practical, so I went with this. What you've got, this is your temperature controller, so your probe, temperature probe input. 3 wires, color coded, so I know what goes where. And these two are the pump output. So obviously this is perfectly safe. It's nothing that can hurt you because it's mounted externally. But it allows you to remove all the stuff without any messing around. Okay, so what happens is the PID controller reads the input from the temperature probe. This is the red temperature, this is set temperature, which at the moment are exactly the same. A PID controller is like a smart temperature controller. A thermostat basically works on the logic, and this is what I used before. It normally has a range, so okay, say the set temperature is 65, and I'd say, okay, an acceptable boundary is half a degree. So the logic is, okay, what is the current temperature? Is it is it half a degree lower than the set temperature? So is it 64.5? If it's lower than that, turn the element on until it reaches the set temperature, which works, but the problem is it always overshoots. So it will turn it on until it reaches 65, and then it'll carry on heating. You might get to 66, 67, and 2 degrees when you're doing a mash is quite significant. So what this does, this is more of a smart thing. You have to tune it. I'm not a mathematician. I can't explain to you the proper PID algorithm and everything, but there's 3 different variables which you mess around with until you get it just right. And it basically compensates, and you can auto-tune it as well, actually. It can work out itself. And it will calculate things like the overshoot and things like that until basically it gets it spot on. And it does it by quickly bursting the heating element on and off, on and off, on and off. And if you look, actually, you can see it working out 1. Every time that lights up, the heating element's firing. So it does it for a short period, multiple times, to maintain a pretty consistent 65, and then it will drop 0.2, maybe 0.3 below sometimes, and then up. But it's pretty damn good, I'd say. I'm really happy compared to what I was doing before, where there's literally degrees of variance. This is fantastic, and I love it. So this is really good, and it's really easy to set temperatures, to change it. It's quite versatile, and it's really cheap as well. Now this, due to the amount of times it flicks on and off, you can't use a normal relay. You've got to use a solid state relay, which is one of the ones that are attached here. And this does the solid state relay works like normal relay, apart from it's got no moving parts, so it can flick on and off loads of times without breaking. So that's really that. So it's just bursting this enough times to maintain a consistent temperature. The other one, the other solid state relay, is quite different and was more expensive. So this is something I've done before. I just moved the parts over, incorporated them into this all-in-one thing. Basically, this can trim just about anything. So it takes an input, and it goes through this solid state relay. It's a special type, which takes a feed from this potentiometer, just a normal potentiometer, and it's a glorified dimmer switch. So I can use this. I can say no power, half power, full power. It might seem like nothing, but it actually, with a high power circuit, it's quite difficult to implement. And this switches the whole thing on or off. Now, because I wanted to be able to turn everything off at once, I want to be able to switch this off and everything be off. I couldn't just have this running on a separate circuit, so this takes a feed from here, this switch, which switches, when I turn this on, it actually turns a relay on over here, which will click on and allow the big high power feed to come through. So it means there's no more stress on the first circuit, but it's all still controlled through the first circuit. One output's there, one output's there. That's pretty much it. It was fun to do, and I'm really looking forward to brewing with it. I'm so impressed with this. The temperatures we're getting, it's so consistent, it's fantastic. So I'm really excited to get a first brew going here. Problems, well, I mentioned earlier, leaky element. Really annoyed me. I've had to seal it up. I'm not happy with that fact. This is down here to leak test it, so I can see if anything drips. If it does, it's really no big deal, because the way it is, it won't short up. I'm still not happy with any leaks at all. So I'm probably going to have to order another element. The problem was there was some cracks. Where the element joins to the body, there was some cracks in the solder. I think it's solder or weld. Either way, not good, right? So I'm probably going to have to order another one. The problem is they're like 3 weeks away, so I've patched this up, and this will do me one brew session, and then I'll have a replacement, by the time. It's just annoying because you'd like to have it all together and done, but such is life, right? The other thing, literally the only other thing, is this little pump. It's a cheap pump, tiny pump, but it's got such a good flow on it. And I've run this on multiple brews for hours and hours and hours with no problem. But the poor little fella, I feel it gets quite hot, and I feel sorry for it. So I might dunk it in a bit of cold, because it's submersible. So I might just dunk it in a bit of cold water, a little jug or something, just to keep it cool. Because I don't want the thing failing. It's pretty good. I mean, you can order a replacement as cheap as anything, but still, you don't want it to fail. It's surprisingly reliable, and it's put up with a lot. These tubes are all silicone. I had used normal PVC the first time I did this recirculation job, and I forgot the fact that obviously PVC will soften under the heat and collapse. So it will just collapse down on itself, and there was so much restriction. I still managed to make it work, but not well. So this silicone doesn't soften under heat, so that's why I use silicone. The real beauty of this thing is you can use the same thing for the boil. Because I don't have tons of space, I don't want loads of big pots lying around. So all you have to do is you disconnect all the RIMS tube. What I normally do, I empty, once I've finished the mash, I empty this into like a spare brewing bucket, and you clear out the grain. Then you can power these two heating elements here and here, and that does the boil. What I normally do, I put one straight into the mains and one to the trimmer. I run them both on full bore until it reaches the boil, then I turn one off, and then I can turn one down to like half power. And it's good because it means you can control it like a gas stove. That's one thing I hate about electric, is it's so sort of, you're either 2,000 watts on or nothing. So with this I can put it down so I can get a nice steady rolling boil without, bubbling up, miles up. Anyway, that's about it. I was just quite excited. I might show you a brew day with it. I don't like recording full brew days because I like to just get some music on and chill out. But I might do show off a brew day with this. I'll probably do one as a test, and once I'm happy with it, I'll show it in action. I'm really looking forward to doing a brew with this. And yeah, that's pretty much it. I think I've said that a few times. So thanks for watching. If you're interested in this sort of thing, let me know. If you want any advice in the construction of this thing, let me know. I'm obviously a beginner in using